What's going on, guys? Wanted to do a little bit of a spotlight that would cover some of the CAD parts that I built out in part one, as I'm not going to touch them too much in part two, but a lot of interesting work went into them. So there's four main parts that I want to go through, and so I'll jump right in with this first one being the geometry, the back half of the geometry of the taillight. I built out a couple of different parts in this. And so I had there we go, the fairing 3D scan that it gave me a pretty clean edge on the inside. And then I also had the taillight scan that I was referencing for this. And from using those as a baseline, I could start to get some of these simple shapes like this arc on the side, a very minor arc on the bottom, and then most importantly, the bolt points at the back. Another one that was pretty clutch to have in here was this kind of like key slot for this geometry piece that I'll show you guys in another part that kind of slid in the back to keep the top half of the light in place. But this ended up coming out pretty clean. But yeah, I did probably like 30 3D prints on this part alone, just trying to get it right and getting it to fit into the bike. And I'll also show the section view. As I mentioned, I wanted to keep this stuff pretty thin, and so this has a pretty continuous 16th of an inch thickness throughout the entire part. No real innovation here, as this information and geometry was already defined in the taillight that came from Triumph. But as I started to build out my own taillight, I needed to basically redo all that geometry and design it for being on a aluminum part opposed to an injection molded part. The next part that I built out was the main face, which I called the baseline part. It gave me the baseline geometry of the rectangular taillight. So this had the 3x5 grid on it, which is very simple. But the part that took quite a bit of time was figuring out the correct size and pattern of the taillight. I knew I wanted to have a 3x5 so that I could do like a 3-2-1 like zero for the one of the animations. So figuring out the pattern was important, but also figuring out this distance between squares and the edge here. I wanted to give enough distance to give me a nice overlap of the diffuser that was going to go in here. Also, not make this face too wide or this part too wide where the thickness and border took away from the actual squares themselves. So this baseline part was very important. And then when you come over into this combo part, see how the parts looked when they came in. So that's the baseline part we were just looking at. And this is the back geometry I was talking about. And this is just a trick that I learned. Splitting up these parts is just a trick I learned from working in aerospace of the less complexity you have in a given part, the easier it is to actually change everything because similar to SolidWorks, using Fusion 360 is parametric. So if I change a detail on one part, once it's been put into an assembly, I can go back to the original part and then edit it, and then the assembly will reconfigure itself and update, and sometimes change features in other parts of the part, and it works really well. So now to start actually making the way through the designing part, you can see I started to make some extrusions that would branch from the baseline part back to the like back half of the part. And since this part was still going to be machined out of 6061 aluminum, you can't just have a bunch of empty voids in here because there's no way for even a 5-axis mill to get access to the inside of this. So you'll see that I actually cut a big window in the back here. And then I actually ended up making a completely separate part that filled in that window. But you'll see I'll clean up some of these lines and cuts that I made on the inside of here. After I got all that cleaned up and did some fillets, I ended up with this main part, and then that would be very easy to be machined, and I got some big fillets in here. And then I also had this second part that I had rectangle in here for a connector to pop in. so that I could be able to get back out to the bike. So this is what the main enclosure looks like. And another thing to call out is that on that back piece, I made some extrusions that would reach out to grab the PCB board. And so these would be threaded M3 holes. So you could put the board right on the front and then bolt it down with M3s, and then the cable would go straight out. So yeah, that's pretty much all to call out for this part. And most importantly, got to have the Pixel Moto logo on the side. The last part to show is the TLA, which is the top level assembly. This has all the parts combined into it. So it has the main diffuser, it has the PCB board that I'll show you guys, it has the reflector, it's got the main enclosure for, of course, and then it's got this space claim for this key feature I was talking about. So I'm actually going to start with this. So this key feature is something that the main bike uses. It does not look exactly like this, but a simplified version of it. And basically, this slots in and then gets bolted in a couple of different places. And since the light was going to need this to be able to mount back to the bike, I wanted to make sure that I had modeled it out so that I could use it to make sure that the slot that I had designed would work with it pretty well. We've looked at the main enclosure. There's no real difference here. And then the three new bodies to talk about here is the diffuser, the reflector, and the PCB board. The diffuser is going to just be machined out of a piece of acrylic. It's just a simple grid. I did a 0.15 millimeter offset for each of the rectangles so that I definitely knew that it would slot into the face of the enclosure pretty well. But it's a really simple part. Next up was the reflector. Is a pretty important part, as the idea here is to go for that 8-bit pixel look where it's kind of just like squares that are glowing. And when the LEDs are just on a board alone, there's a ton of LED bleed and light bleed that's going in and out of each other. And so I wanted this reflector to also be kind of the blocker would allow it to allow the LED to only shine through the given block at the given time and then project that onto the diffuser. To show the PCB board, I actually jumped into another part to make this, to give you guys a better idea of what this thing actually looks like. So on the back, you have a bunch of different components, and then on the front, you have the different LEDs. And what you see here is both red and yellow LEDs along the edges on the sides, and then you've got just red in the center. This will make sense when you see the videos come together. We got the yellow for turn signals, and the way I'm doing turn signals is just having them be straight lines on the side. This might change in the future, but yeah, it's the PCB.